with prime focus on holistic learning and imbibing competitive abilities in students. The university feels pride in being the only multidisciplinary campus in Delhi NCR, spread over 63 acres and equipped with world class facilities. My dear friends, this is the second day of this international FTP themed on recent advances in computer science and allied domains. And we are really very happy to see the feedback submitted by the participants after attending session on the first day. We are very thankful to all our participants for their sincere listening and positive attitude towards the talks. I now take this opportunity to introduce our guest and speaker to the audience, Dr. Hardik A. Gohel. Dr. Hardik Gohel is a director of research in Department of Computer Science at University of Houston, Victoria. He is also serving as an executive director of Applied Artificial Intelligence Laboratory at University of Houston. His research projects have involved cyber test automation and monitoring, smart bandages for wound monitoring, big data for security intelligence, trustworthy cyberspace for security and privacy of social media, predictive maintenance for nuclear infrastructure, and database and mobile forensics infrastructure. Dr. Gohil is also working on how to prepare quality, diversified workforce with artificial intelligence in STEM education. Dr. Gohil is actively working with United States federal funding agencies and national labs for research collaborations. He is also interested in linkages and signing MOUs with government, academia, industry, and international bodies to foster individual and institutional partnerships in a natural and sustainable manner. My dear friends, Dr. Hardik is being accompanied by Dr. Suresh Kumar Peduju, a postdoctoral associate at the Applied Research Center of Florida International University. Dr. Peduju has 15 years of professional experience, which includes teaching, industry, and research. He has several publications in highly reputed journals from publishers like Springer and conferences from IEEE, ACM, etc. Currently, he is involved in research to build robust cyber attack orchestration testbed for automation and threat monitoring in virtualization environment for malware detection and monitoring. He is actively doing research and development in virtualization technologies, smart memory acquisition, and studying real-time malware impact on the mission. He is supporting the advanced cyber analytics team for cyber forensics. With this, may I now request Dr. Hardik to kindly take over and address the audience. Dr. Hardik, over to you, sir.
Thank you, Dr. Arun. Very good morning to all of you, uh, and namaste. It's my pleasure to be a part of this talk. But basically, I am busy in one federal agency proposal that we are working on, and due to that reason, the problem is I couldn't prepare the talk for today. So my colleague, Dr. Suresh, he's gonna give a presentation on IoT, and basically he is an expert of cybersecurity and IoT, and he is gonna speak extremely well on that. Another thing that I'm gonna, I'm gonna convey from my side that in my university at University of Houston, Victoria, we are working in a different multidisciplinary research, and that research includes that what Dr. Agrawal mentioned. Other than that, we are also actively looking for candidates like PhDs and postdocs. Those who are interested to pursue like summer internship, online internship, they can reach out to me, and yeah, I mean you can get my contact information online by searching my name Google, and you can reach out to maybe Dr. Vishal and Dr. Arun for the any kind of contact information or connections if you are looking for. And if you are looking for like learning more about what kind of research we are doing at University of Houston at Victoria, you can search over the website. And I'm also going to share our lab links with you guys, so you can look into the research projects that we are involved in. So basically, like, I'm not gonna speak more about anything, but let me, share a little bit about my work, that what we used to do and what I have done so far. So I'm gonna take only like 5 minutes from Dr. Paduju. So basically, just a second. Yeah. So basically, this is all about me. That my academic qualification, I have done a PhD in a computer science. My dissertation title is Investigative Study of Social Media and Development of the Social Secure Web, that I have done in 2015 from the University of Hertfordshire, England. Our research area of specialization at lab, and especially my area, that I would say like artificial intelligence, cybersecurity, digital health, virtualization, and social media. In my entire research portfolio, I do have 4 books, 2 book chapter publications, and more than 50 publications in the journal and proceedings of national and international conferences. The bit little about like my PhD research, that what I have started from 2010 and what I have achieved so far. That basically in 2010, when the social media was very much new and booming into the market, I started working on the social media. And what I have learned, that most of the researchers were focusing on the unstructured data storage, management, and retrieval. And there were a very huge research gap, that how we can obtain critical information from the social media, and also like the security issues related to the social media. And then I proposed the solution architecture, that is a social intelligence, which is applied AI on the social media. And that is a combination of the data mining as a social mining, and the semantic web as a social semantic, and data and information retrieval and warehousing. I'm not going to go into the details framework, but here you will be seeing that this is the general, highlight of the framework, that the Facebook and Twitter, both social media, was targeted with customized API, and that customized API was collecting the data of the social media and doing the visualization, that known as the social intelligence, and was also detect. I mean, before 2010, it was not like encrypted data, but after like 2010, there were encrypted messenger systems for sending and receiving message. So by using the machine learning techniques, we were able to detect, suspicious instant messages if somebody is sending using the instant messenger. So that is was like little, broad framework. And the broader impact is like, you can get the perceptions about the information that floating on the large amount of the data, perform the data sampling and analyze, that can be used for the medical governance and businesses, monitor suspicious activities, e-crime of the social media, and also the prediction. So that's what all about my, PhD research that I took like a little long, started in 2010 and finished in 2015. So it was like a little long for my, learning and study purpose. Thereafter, like, right now we are doing a different research at our research lab. And basically, I have joined University of Houston, Victoria as a director of research and the executive director of applied AI research lab. And we are also going to convert this research lab into the research center um, at university level, which will be the applied AI research center. And the different federal agencies that we are targeting for the funding. And we are also looking for international collaboration. So obviously our interest is to collaborate with the India and Indian universities and the researchers. Basically, we are also looking for like, research partnership, that is a MOU kind of things, where like, your researchers can come over in US and can use our research facilities to perform research tasks and publish papers together, and also filing a patent. So I was talking to a couple of folks in India last week, and they said they are interested to file some US patent but they are running out of the budget. So I told them if you really think that you have a really extraordinary idea and you would like to collaborate with us, then I do have a budget from my university, which can be considered as a part of collaboration, and we will we can jointly file the patent from my university as a collaborator, and from you as an individual, and from your organizations. It could be anything. So basically, we are working on the AI at edge. So that is the auto sensing systems. So basically, traffic detections and autonomous driving, car location training, AR, VR, safety monitoring things, and all those kind of edge intelligence that we are working on. The details of this information is available on our website, so you can look into that. That what kind of uh, federal projects that we are working on AI at edge. The second one that we are working is a cognitive robots and drone. So basically, we just recently started IoT, simulation things and development at our university, and we are trying to, create some cognitive robots and drone that not only helps war kind of things, but also help in the medical system. So basically, nowadays, due to pandemic and COVID-19, we need to maintain the social distancing, and we also need to provide the emergency or urgent care. So that can be also possible by using cognitive robots. Okay, so all that information is also available on our web. The third one that we are working with the cyber physical system with respect to IoT, and that cyber physical system is connecting let's say our laboratories that can be accessible remotely, connecting the classroom. So let's say due to pandemic we were not able we were not providing face-to-face classrooms. So the classroom which is online but which also gives the interaction of the face-to-face, and the labs which is actually located physically to the campus, but people can access all these resources from anywhere, and that is by using those old simulations, the cyber physical systems that we have developed, and that worked very well in the prototype development initially, and we are still working on it. The another one that adversarial machine learning. So that is also one of the frequent research that we are doing at. So what we are doing, we are collecting a lot of data, and very quickly we are building the machine learning models. But now what we were doing is whether the machine learning model is really accurate or it is still vulnerable. So we are trying to attack the machine learning model and perform some adversarial attack and try to identify whether the machine learning model is able to predict accurately as per the accuracy it is providing, or there is any misrepresentations of the predictions. So these are the projects currently we are working on, and all these details of the projects I wish in next future session that I would be working with Sharda University. I'm going to present our research findings over there, and further that Internet of Things will be presented by Dr. Suresh Kumar Pedoju, and that's it from my side. If you guys are having any questions, any concern, you can reach out to me, and you can send the questions and any concern to Dr. Vishal and Dr. Arun, and we will take it from there. Okay.
Thank you, Dr. Hardik. Thank you so much for sparing your time and discussing your domains you are working in, and your open invitation to all our participants if they are interested in collaborating with you in any of the way, being a postdoc researcher or filing any patent. We
Yes.
are very thankful to you for giving such an open invitation to all the participants. And my dear friends, let me tell you that he has not slept for last 2 nights, and he has a delivery, means he has to deliver a project of Department of Defense of US on 25th. That's why he is so much busy. So thank you, Dr. Hardik. And may I now invite, but I would like you to kindly talk to Dr. Suresh. Actually, he was with us just a few minutes ago, but I can't see him right now. I think he lost some connection.
Dr.
So
Arun,
may I request Dr. Hardik to kindly talk? Yeah.
He's here.
Okay.
He is here.
Arun
He
sir
has
is
joined.
here.
Yeah, he has joined with some different
yeah,
name.
yes,
Yeah. Dr.
I
Suresh, may I
joined
Dr.
with
request
other
you
Suresh.
to
name, but
kindly rename yourself? May I request you?
yeah,
Dr. Suresh, can you just, open your camera so participants can see you?
Yeah.
And then thank you, Dr. Agarwal, and
Yeah. Thank you so
thank
much,
you,
sir.
Dr.
Yeah.
Vishal. And
Thank
I
you.
really apologize. I mean, consider my sincere apologize that I couldn't speak in this talk. But I will look forward for further, collaborations and future talks as well.
We'll catch you later, sir, in our conference. We will organize, or we will definitely schedule a keynote address by you in that conference so that more people can get benefited. Okay.
Thank you. Thank you
And
so much,
best
Dr.
of
Agarwal.
luck for your project delivery, sir.
Yeah,
Thank you.
thank you. Thank you so
Yeah.
much.
Thank you, Goel sir.
Thank you, sir.
Yeah,
Yeah.
thank you, sir. Thank
Dr.
you.
Yeah. Dr. Suresh, over
Okay.
to you now, sir. Over to you. You can share your screen, sir.
yeah. Thank you, Dr. Arun Agarwal ji.
Yeah. Thank you, sir.
And I wholeheartedly congratulate all the participants who are as part of this international FDP. And at the outset, I would like to congratulate all the management and the team of Dr. Arun Agarwal for conducting the international wide FDP so that everyone can get benefited from that. Thank you. And thank you, Hardik, for proposing my name, and thanks for the management to agree on that to present my views on IoT Edge and related machine learning research what we are doing in Florida International University.
Most welcome,
Okay,
sir.
thank you. Let me share my screen so that we can go ahead from there. Yeah, can you able to see the screen, right?
Yes, sir.
Okay, thank you. So yeah, as Dr. Arun Agarwal introduced my profile, like I am Dr. Suresh Kumar Pedojo, and I'm currently working as postdoctoral associate in Florida International University. And my current research is in cyber analytics as well as uh, IoT analytics. So, which includes like real-time monitoring of threats which are happening at cyber physical infrastructure as well as IoT related infrastructure. So yeah, uh, let us. I mean, today I'm going to discuss about what we are doing at our lab here in Florida International University as part of one of the NSF project which we are currently doing, and I will go through like some of the content of that, and even I will try to like give you some demo part of it. So this is how I planned today to discuss. So initially I will start with the basics of Internet of Things, that is IoT, and then I will go over how Azure IoT can be used to address the IoT things, and I will go over demo part of how to establish a IoT device and how we could able to connect it to the Azure cloud. Okay, then we will discuss about like what is edge computing and how edge computing is like it will work and what is the life cycle of that. And then I will gonna discuss about the actual framework what we have implemented here, and on uh, on that how we could able to monitor real-time data. So that I will gonna discuss. Then I will try to show you small demo of how like automated machine learning can be used for analyzing real-time data. So with that, I will conclude the session. So this is how I plan to deliver today. Okay. So as you all of you know that Internet of Things is a gain of network, right? It is connected things. The thing can be of like any real-time entity that may be bulb, or that may be AC, or that may be refrigerator, that may be plane, that may be anything, right? So nowadays, if you see the latest news from Samsung, they have invented a refrigerator which will like give you indications. What is the status of fridge? What kind of materials are there in that, and what vegetables are like damaged in that, and uh, what ingredients should be there in the like what type of things should be there in the refrigerator, and what is like which are left over and which needs to be fulfilled for further to be refrigerated. So those all things it could able to give the analysis and analytics over the goods which are like stored in the refrigerator. So that is how now the stage of Internet of Things is happening. To give an example, this is how the IoT and incorporating intelligence into the things, right? So how it will be helping the people that we could able to understand with that example. So by said that, so this is how the Internet of Things will like work. So if you see from connecting device to human value, we could able to get it from this cycle. So within the cycle, if you see the first step, that is device connection. So IoT devices, which basically the things what we are talking about, the refrigerator or AC or the plane, the drone. I mean, you could take any real-time entity that could be a thing, and that could have IoT device, you could say. Okay, so from there, it will generate some kind of data, and that data can be captured through the sensors. Okay, and the sensor captures data will be like communicated or over the network, and it will be like stored in cloud or on-premises storages, vice versa. Okay, and apart from that, once the data is in the storage entity, either it may be on-premises or the cloud, then it will be like analyzed. What is the data which we got, and it will be applied some artificial intelligence techniques on top of that data to get insights out of the data. So that insights will give us a value, right? So based on that value, based on that insights, we could able to make decisions, we could able to make actions based on the insights what we achieved from the data which we collected from IoT devices, from where we could able to betterfy the value of human life. So that we are getting in the form of like smart applications and all other like digital infrastructure what we are seeing nowadays with the IoT devices, that will definitely give value to uh, human life. Okay, so if we see like the functional overview of IoT, then basically what it will be like kind of these 5 steps. Okay, create, communicate, aggregate, analyze, and act. Okay, so basically sensors, or you could say like physical devices which installed with sensors that will create or generate the data, and then that will be communicated over the network to uh, the integration part, that may be like storage, right? That may be storage or like storage entity, that may be on premises or uh, on premises or the cloud, right? And over there it will be like processed and analyzed, and then based on the analysis it is gonna um, react what we need to do further on the analyzed data, right? So during this process, if you see here like um, sensors, as I already told you, which is part of physical devices, and the network, if you see, these are processing elements, and which will connect uh, IoT device with the cloud or other storage environment. And then aggregation will be done at the middleware, that is IoT hub, or like kind of um, facility will be there. And with that, either it may be structured or unstructured, whatever kind of data it may be, that will be like integrated and aggregated, and it will be like stored in the data storage. And on top of that, then it is the part of analysis, wherein we will be doing like processing that by using like if it is static data, uh, then uh, we are gonna like apply basic machine learning algorithms to process the data. And in some applications we need to do it as a stream analytics, or you could say in simple words, data in motion, right? In that case also we should able to analyze the data which we are getting it from sensor devices. And then of course we should act on the insight what we got it from the uh, data. So this is how the functional overview we could say when you are talking about IoT infrastructure. Okay, so we have like discussed about what is IoT, and how internally the IoT structure would be. And just to share few things about the prominence of IoT. If you see, like there are multiple applications nowadays we could able to see in the market. So it may be home automation, health monitoring, smart animal farming, industrial control, defense systems, security, emergencies, even smart water, smart environment, smart cities, smart agriculture, whatever application you take, like nowadays we could able to um, use IoT in that um, as part of this. Okay, if you should see the division of individual area, then healthcare is like the most prominent area where we could able to see the value of IoT. And apart from that, manufacturing uh, is also one of the prominent area where we have a major contribution of IoT. And of course, other parts are like different application areas. If you see, like they have their own contribution among the IoT. So this is what the projection which will be there for 2025 means. If you want to really work on IoT research, then I would prefer. I mean, I would say that you have like a major area at healthcare, and apart from that, you have manufacturing. These two are like dominating uh, in coming 5 years. So yeah, so this is what my like suggestion for the researchers who want to do proceed for IoT research. And specifically, if you talk in the terms of Asia specific IoT contribution, you see like um, here just to see this blue thing is China. So China is spending like IoT spendings are 65% in compared with all Asia specific area. If you see 65% they are contributing, they are spending on IoT. Okay, and if you see the India, then it is like almost 8%. So which is good, but it should we could able to increase that by contributing or by spending IoT over there. And if you see the other countries, so this is how they, that means what I mean to say is, for our India, we could like there is a lot of scope. There is a lot of scope for IoT spendings and IoT research and IoT contributions that can give like more value and more insights for governments as well as the people of India. They can get benefited out of this research. Okay, so yeah, there are like always there are pros. If we have some pros, then obviously we should have like some disadvantages with the system. So as you see here, like this is home automation, and this is like automated car, and then here is the person like who has like installed IoT devices with him, wearable or installed IoT devices. So the problem is like every IoT devices are like have a scope of some kind of threats. Okay, so if you take like home automation, so there is a scope of attacking the any IoT device which is installed as part of home, right? So in recent times, I have heard one news here in US. So one of the couple, like they were sitting in the home and they were watching TV. So suddenly, their home appliances started like behaving so weird. Like the sound system is automatically increasing the volume, and the TV is shut down, and AC is increasing like very high, low, right? So such kind of things are happening. Suddenly they surprised to see like they are not operating anything, but In fact, it is operated by some other intruders, some other people, outside people. They got control over the IoT devices. Okay, so that is more or less it is fine. At least there is no much damage for the people in this example. If you go on to the automated car system, then I mean, you know that automated car is installed with many IoT devices. So if I got control over the IoT devices which are installed in the automated car, then obviously I could able to like drive the car, and I could able to do whatever I can do in the traffic and do with the people. I mean, if I have like bad intentions, then I could able to do whatever I want. I want to do with the car, right? So that is like one of the problem we could have with the automated car systems, and yeah, the threats which could able we could able to get it with IoT devices. And apart from that, if you see the third example, that is human itself is installed with IoT devices, and then for example, if you have like um, insulin pumping device is installed with us, right? So if I got control over that machine, I got control over that IoT device, then obviously I could able to operate on that device to inject more insulin, or like kind of things I could do, right? And if you could able to have like pacemakers, like automated pacemakers, then if I got control over that, then you are done, right? So such kind of problems and such kind of information like stealing can be done with the IoT devices. So there are like many advantages as well as uh, some disadvantages with each and every system which is like in the market. Okay, by said that, so Azure, like Microsoft is providing IoT architecture, which is like the motto of this IoT architecture is like things, insights, actions. So things, if you see here, things may be either devices or IoT edge. I will talk about this in like next coming slides. And then this is how it can be communicating the generated data for the ingestion for the storage purpose. And then here are some storage as well as analytic functionalities which could be used to handle the data, to process the data. And then that can be like that can be applied on by using some kind of machine learning capabilities on top of that data. And then the insights, the actions can be given to the user in the form of like applications. Either it may be like mobile applications, or it may be like Power BI or some other kind of applications. So this is how Microsoft is providing the architecture for IoT. So if you want to experiment, you could also do that in a Microsoft Azure platform. Okay, so just I want to show you one demo um, how a Raspberry Pi device can be connected to IoT hub. By that way, how we could able to get the information or get the data which is generated by the device into the cloud. That we are going to see as part of demo. So initially we will be creating IoT hub in the Azure cloud, and then we will add the device which we want to add to the IoT hub, and then we will try to test that environment by connecting to Raspberry Pi simulator uh, device, and we will send data from that, and we could able to see how the data can be like received at the cloud end. Okay. Let me stop sharing this, and I will going to show you the demo. So do you have any questions or any concerns so far?
If any of the participants is having any question, please write on chat box so that sir can answer that accordingly.
I think there is no question in the chat
Okay,
box.
no problem. I am trying to connect it to Azure. Just give me a moment, then I will try to share the screen.
There are few questions, sir, in the chat box. Arun, sir.
Sir, now we have some questions in the chat box.
Yeah, I will look into that.
So, should I read it for you, sir?
Yeah, please.
Yeah. What do you feel about smart cities in India?
Yeah, basically, I would say that we have lot more opportunities in smart cities research, and of course, like there is much research is pending, I would say, not only in developed countries, in any like ongoing like developing countries also having many challenges with smart cities area. Yeah, there are more, lot many more scope is there in that area.
Yeah. There is one more question in the chat box, sir. Between
Yeah.
Azure and GCP, which one is better to analyze the IoT data?
I would suggest Microsoft like Azure instead of like GCP, which is like proprietary kind of thing, but as analytics, if you see, then it is a lot better than GCP, as per my understanding.
Okay, thank you, sir. And there is one more question. Person is saying that I am a research scholar using deep learning algorithms. And then I think the question, just a minute, sir. Yeah, I'm a research scholar using deep learning algorithms in IoT devices. How to maintain security in such perspectives?
Yeah, I'm going to discuss about that in my coming slides. So my talk is about that only. So probably
Sure.
after my talk, maybe he can understand that.
Yeah, I can see one more question.
Yeah.
Is Azure Hub based development is predominant in developing IoT based systems using Raspberry Pi or microcontroller than using other hub?
I mean, That is like a tricky kind of question, but I would say any device which is like generating data, either it may be Raspberry Pi or any other device, doesn't um, impact that much. But obviously, we are more concerned about data, and and on top of that, what analysis we want to do it, and what insights we would like to get it from that. So that is more of our concern.
Yeah, okay. So you can continue with your talk now, and we can take some more questions at the end of the session now.
Okay, thank you.
Yeah, welcome, sir.
So can you able to see the screen like a portal, Azure portal? Sorry?
Yes, sir, we can see now.
Okay, no, thank you. Okay, so what I will do is initially I will create a IoT hub. Okay, so I will create IoT hub here, and then as I told you, like I will attach one device uh, to this IoT device, IoT hub, and then we will use like a simulator to generate data and ingest the data to IoT hub. Okay, I will discuss these terms later, but just I want to give like a small overview of how IoT and IoT devices and cloud is related with this example. Okay, so here, so in the Azure portal, okay, let me like first give you a small overview over this. Okay, so this is Azure portal, wherein we could able to like see lot many services within this. So if you see here, like uh, there are lot many services like uh, resource groups, marketplace, right? So different kinds of services we have. In general, if you see compute, so compute related means if you want to have like computing resources in the cloud, then you could able to like select any one of these, and you could able to create instantaneously. So that is the advantage which we have like with Azure. And networking related resources, storage related resources, web related, mobile, right? Container, databases, analytics, and so on. Like you see like lot many categories and a lot many services Azure is providing, which also including like Internet of Things. Okay, so so among these, just I would like to like create IoT hub. So okay, so this IoT hub is a resource in the cloud, and if you need to add any resource, then that resource should be added to uh, one of the resource group. So if we have already created one resource group, then you could attach this resource to that resource group. Otherwise, we could create a resource group by clicking on create a new button here. So which will create, and of course region, we are here in Florida, means it is East US. So they have like uh, cloud sections are divided into regions, and in our India also they have like Central India, right, North India, South India. So three regions they have uh, their data centers. Okay, and we have to give some name here. And because we need to have this public endpoint, because we would like to communicate with IoT device to this IoT hub. So that's why I'm giving networking as like public endpoint. And these are the like pricing related tiers. So I am on like, you could also have subscription with Azure as a free of like 30 days plan, wherein you could able to get like $200 credit, and with which you could able to create the um, some of the resources, and you could able to use the platform for like experimental purpose. Okay, so as part of that, we have like limitations in the provisioning of resources. So as part of that, I have chosen the minimum pricing model for this IoT hub. Okay, and of course, we could segregate the resources into different categories by tagging them. If you give name like Department of Computer Science, then these resources will be like categorized into Department of Computer Science and Electrical and so on. So that is the purpose of tags here. And of course, like once we go over the review process, and then we could able to create the um, IoT uh, hub. It will take like a few seconds, and you could also see the status of uh, the resource which is being created over the cloud, and you could see deployment is in progress and for this resource group which I created now, FIU. Once the deployment is done, then it will show us deployment is completed and the resource is ready. So that is what I'm saying, like you could instantaneously create the resources, either it may be storage, network, or computing. Like if I need virtual machine, then I could able to create the virtual machine within this platform within few seconds only. So that is the advantage which we have with this Azure platform. Okay, so it will take some time to create. So once after it creates the IoT hub, then we need to attach IoT device. Which device we need to like connect to the IoT hub? That device we need to choose, and you could say like it is interface between IoT hub and IoT device, which will interconnect the device as well as uh, IoT hub. Okay, and meanwhile, I will try to bring. I will try to bring the. Okay, so You could see here the device, or you could say the virtual IoT hub resource is created for us. Okay, so now if you see uh, the left pane here, so in which you could also see what kind of logs this particular device is having, and what kind of security provisions are there with this device. And as I already told you, the tags, about the tags, and if we have some problem with the devices, the resource, then we could able to diagnose and solve with this. Okay, and of course there are like a lot many um, categories and lot many information we could able to see and observe and make decisions over this IoT hub with the help of setting up these properties. Okay, so as I already told you, so for this IoT hub, we are gonna attach one device. So that is what we are doing here. This IoT device I am attaching. Okay, so just click on new button here, and it will ask us for device ID. You give some name, my uh, mobile device, for example. Okay, just I will say save. Then IoT device is now created. If you click on that device, then you could see the connection string and the key values for this device we could able to see. Okay, so now what we have done is we created IoT hub, right? And we attached a device. We attached IoT device with it, right? This is the device. Now we are gonna connect this device with the actual IoT physical device. Okay. So instead of that, what I am doing is I am just using a Raspberry Pi simulator. Can you able to see the simulator?
Yes, sir, we
Yeah.
can see. We can see the simulator.
Okay, perfect. So here, here we have like one board wherein we have light is indicating here. So this is the code base for this circuitry thing, right? It is already pre-built code which we have. Only the thing what we need to do is to get connect to, because as I already told you, this is a you assume that this is like a IoT device wherein it has a smart bulb kind of thing. Okay, so what we are gonna do is like we will connect this device with IoT device which is connected to IoT hub. Okay, so for that we need to have the connection string to make the connection with this device. So just copy this connection string, and then if you see the code over here, it has a pre-built-in code, and you could see here connection string it is asking. So we have to replace our connection string, our device connection string, which is connected with IoT hub. Just I am going to copy that particular string. If you see here, now my host name is IoT, my FIO IoT hub, right? And my device ID, if you see here, my mobile device. And shared key of that one is this one. Okay. So now we have given connection string for this device. That means the data, if it generates some data, then what we are saying is, if this is generating some data, then the data should be uh, connected to IoT device which is attached with the IoT hub, and it should ingest the data into the cloud. Okay, so that is the purpose of this simulator, and with which we are sending temperature and humidity data. If you see here, like code base, we are sending temperature and humidity data uh, to the uh, hub. Okay, so once after we change this connection string, you just click on the run command over here, which is command line. So once if you click on this run, then if you see here, it will send one message, and you see the bulb is like enabling. Once after the message is sent, the bulb is like switching on. Okay, so that means what this simulator is doing, it is generating some sensory data like temperature and humidity. Once after it sends that message to cloud, then the bulb here is like switching on. Okay, so we are assuming that the data is now being sent to the cloud, and now it is uh, storing in the cloud, right? So let us go now to the IoT device, IoT hub, you could say, right? This is the IoT hub which we created, and if you see the statistics here, go down, then you could see here what is the status of how many number of messages are used, and uh, device to cloud messages, how many messages we got, right? And how many devices are connected. Those all information we could able to see here. Okay, so right now it is sending data, but still cloud is not able to uh, get the data. So there is some lag between data generation and storage in the cloud. Okay, so let me try to go back, metrics kind of thing. Okay, and let me see here. If you want to see, like there are lot many options you have. Just I want to see how many messages are sent, telemetry messages sent. Okay, so if you see here, uh, see here, like there are some messages being sent now. So 44 messages being sent, though if you see the this one, it is already sent 80, 81. Okay, but if you see here in the cloud, then it is still 44. Okay, so that means there is a lag between data generation and data ingestion, and it is affecting at the cloud. Okay, yeah, so this is what I want to show you, like how a small IoT device will get connected to cloud, and how the data can be um, inserted into the cloud, and what is the lag during this process. So that I want to emphasize for this demo. So everyone is clear on this? If so, I will be moving forward for like. Okay, so this is how we could see how the data is being sent, and now you could see 74. Okay, previously it was 44. So like that, uh, data generation to storage, there is some lag. There is a lag between like sending to receive to storage. So general IoT devices will have this uh, impact, this issue with the IoT devices. Okay, let me stop this demo and again go back to the PowerPoint. So for this reason, uh, we are like talking about like edge computing in this session. Okay, one moment, please. Okay, so what edge computing like allows, right? Data from IoT devices to through edge. So if you see here the architecture of edge computing, you could say 3-layered architecture. If you say, then IoT devices, either it may be smart devices or vehicles or connected systems, whatever you talk about. So I'm saying that as one layer, wherein the actual physical devices will appear in that layer. And on top of that, the data, with whatever data is like generated, that data will be like uh, pass on to the middle tiered infrastructure, that you could say it as edge. And within that edge, we could able to process the data as part of local processing, and we could make some decisions out of here. Okay, and and of course, once after we make some decisions to send data to cloud, really it needs to send data to cloud, then we will send it to the cloud. So this is how like the 3-layered architecture of edge computing uh, will appear as in the diagram. Okay, so what is the benefit of IoT edge, right? So basically, uh, we could like react in near real time to local changes. If you see the previous demo, there is like a lot more gap between data generation and storage, right? So for example, if any application which needs urgent urgent need of reactions, then it is not happening, and we could see the demo, right? After like generating almost 40 plus telemetry messages are lagging between generation to storage. So during that process, we could not able to make the decisions, right? So that is where this IoT edge will help to react on real-time local changes. Okay, and of course we could able to manage the devices. For example, if you take like um, uh, procliners, for example, if you take procliners, if they have IoT devices installed, and for say if that procliner is like installed at a remote place and it is doing its work over there, okay, and I'm sitting here and I'm controlling that device with IoT network, right? So just imagine that if we have a capability that the proclinet itself make decisions, and it could able to do processing of data over there, and it could react on the local changes which are happening at that moment of time. Okay, so that will impact more. So that's how these IoT devices are more like prominent nowadays, and people are rigorously using, and which is like a prominent area for you to work, and for you to like contribute more for research. Yeah, of course, healthcare point of view, if you are talking about, then these are the wearables the patient is having, and by using like low power wireless infrastructure, the sensor data can be ingested to the edge computing gateway, wherein the data can be uh, analyzed, and some portion of data can be analyzed. Primary analysis can be done at the edge, and of course based on the decision, the diagnosis result or the alerts, if it is required, immediate attention is required, then they are going to give that actions, insights to the patient, to the doctor, and whoever is concerned for that architecture, that can be done uh, at the edge level itself. Okay, so basically this is how the edge network will work. So this is IoT devices which I talked about, like you could assume that this is a procliner, right? And which is installed with sensors. Uh, okay, and then for say if this device itself is having IoT device with it, and it has like sufficient infrastructure, runtime infrastructure, which could able to manage, and which could able to apply some machine learning techniques over here, and it can make some decisions at the edge device itself, and based on that, the data which is required to move to the cloud, then that will be moved to the cloud. Otherwise, that data can be like stored in the local IoT device itself. Okay, so this is how it will be working, and um, it will have three components, you could say. IoT edge modules. You could see here three modules we have, like based on the requirement of the application, the modules can be installed, and based on the purpose, the module container uh, will be installed with the code base, and accordingly that particular module will run. And for running this module, we should have certain runtime environment wherein the modules can be executed under this runtime environment. Okay, of course it will have local storage also. So even though if any communication gap between IoT edge and the cloud happens, then also the data can be retrieved from the local edge device itself. Okay, and you could see here like the simple processing and complex processing perspective. If you talk, then um, basically the IoT device will generate data, right? So the lower layer, this is IoT devices, and these are edge devices. Okay, and if you see the IoT device is generating some data, and which is being like handled by the IoT device. Okay, automated car. This is indicator within indicator device, IoT device in the car. So which is like a IoT device, and this is IoT edge. And if this automated car itself can make the decisions, right? How that intelligence this car is having, that we will discuss in coming slides. But for now, you assume that this car is uh, processing the data over here, and it is making some decisions over here, right? So like that, uh, all other IoT devices and IoT edge devices will be processing. If it is simple processing, then it could able to do it at the devices, as well as if it is complex, then major processing can be done at the cloud, and remaining can be like transferred to the uh, IoT edge and devices itself. Okay, so this is basically the complete life cycle of IoT devices, which we are talking about. Okay, so on based on this, we have like working here by like devising the architecture with the IoT device and runtime, and any cloud environment. Either it may be Azure, or it may be GPC, or whatever like cloud platform you want, then you could use that as like SaaS platform, and then this is how we are like working. And this is the architecture of the framework what we are doing here. These are like IoT devices, either it may be like a smartwatch or smart devices, whatever it may be. Okay, and which will generate the data and which will ingest data to like edge device. Okay, so wherein this edge device will have like IoT hub, and this will like send data, telemetry data, to like uh, IoT functions. Okay, and these IoT functions will make use of the deployed machine learning model, which we are making either on premises or in the cloud. Just we are gonna deploy those models over here, and we incorporated this module in IoT devices to make the decisions over here. And the models, model building and the deployment of models we are doing um, on premises right now, and we are gonna like extend this to like uh, cloud and other platforms, which here in NSF and DoD people are expecting those kind of infrastructure from us. Okay, and of course, as you know, IoT hub like uh, this device will send data, batch or stream data to IoT hub, and it will store that data uh, in storage component. Okay, and of course, cloud is also having this model, and wherein it could able to like build the models and deploy the models at the cloud itself. And of course, all the visualizations which we are doing with the help of Power BI, we could able to uh, show the analytics over the web application. Right now, web application, it may be mobile application or any other application which you would like to show user interface for the user to understand what's happening with the data which is like getting it from the wearables. Okay, so this is how what we are doing, and apart from that, apart from this, we are also like doing this machine learning module. We incorporated at IoT device itself instead of IoT edge device. Uh, we we could able to like deploy this module, machine learning module, at IoT device, and we could able to deploy our models over the IoT devices, and that is how we are doing here to improve the current framework. Okay, so said that, that is the architecture what we are doing, and let us like again coming to the coming to the um, machine learning perspective with Microsoft Azure, then it has Azure machine learning service is there with Azure portal, and then with which like we could able to train, deploy, automate, manage, and track machine learning models automatically, as well as automatically, as well as with the design we could able to do it. Okay, so why we need this? As I already told you, like we could able to do it automatically. So that means automated machine learning algorithms we could able to generate. This Azure will generate, and it will give you the best model among different couple of models. Okay, and of course, which can be easily scalable. Means if you are creating any models, or if you are building any models on premises, that may be scaled to cloud. That is another advantage which we have with this. And of course, it supports many open source frameworks and tools. And yeah, even DevOps kind of workflows also can be managed with this Azure ML. Okay. Of course, it can be used to deploy the models in cloud as well as edge. Okay. So this is general architecture of Azure ML. So here, if you see like um, different kinds of models, either it may be computer vision or speech recognition or any other related fields, kind of models are already pre-trained models are there. So there are pre-existing models also there. If you want, you could experiment that for like learning purpose, initial purpose. You could use this platform to like get experience with IoT analytics. Okay, and of course, it underlying it will be using like different frameworks like PyTorch, TensorFlow, Keras, right, Onyx, and so on. And of course, the productive services it will be using like machine learning, Azure machine learning, and underlying infrastructure because of its extensive data centers Microsoft is having, which will have like good infrastructure like GPU servers and FPGA kind of um, uh, infrastructure which can accelerate the deep learning works. Okay, and of course the deployment of the build models can be deployed on premises, cloud, or edge. Okay, this is how we could able to do it. Okay, and then if you see the what do you say, like end-to-end workflow, then initially we will be like preparing the data, right? In any ML modeling, this is like a primary task. We will be like preparing the data, and then um, we will try to like build the model with that data, and we will train the model with sample data, and then we will try to test the model. Okay, once the model is like giving good results, then we could able to register that model as a service, and uh, and of course we could able to like make it image out of that model, and we could able to deploy that model into the cloud as well as edge, wherever you want. Like it will be like uh, endpoint connection, wherein you could connect and you could deploy that model into the device, whichever device you want, where you could able to deploy it. Okay, so just I want to go over like classification model, as already all of you familiar with that. So just I'm not going into the details of classification model and so on. Just I would like to show you how automated ML can be used to create classification model, and how it is, how easy it is to create the uh, models in automated machine learning platform that we are gonna see now. Okay, so yeah, of course, I'm using like bank marketing data, right? Uh, which will have like different parameters in which the Y column will be indicating the customers who are subscribed to fixed term deposit, and that will be our target column. Okay. Of course, these are the steps to create that. So initially we will create the machine learning component in the portal, and then from where we will create the workspace, and within that we will create a ML run for it, automated ML run for it, new automated ML run, and then we will load the data set, and after that we will try to like give the configuration, um, certain configurations for it, like metrics and what computing resources it requires. Such kind of information we are going to give um, uh, for that run, and then we will see like which algorithms are giving good results out of that automated process. And the metric which we are going to see is like uh, AUC weighted metric. Okay, and later we will try to deploy that model uh, into the devices wherever you need. Okay, this is a complete overview, and let me share the Azure portal, and we will go over from there. Okay, so almost 780. This time stopping now. You see here, when I stop it here, the bulb will be not active. Okay. So 763 messages we have. Okay, so just I'm going to create a Azure machine learning service here under FIU group. I'm giving name for it like and I'm keeping remaining things as defaults. It will take some time to create. Okay, so the service is created now. So when you say launch studio, then it will gonna open ML studio, that is Azure like machine learning studio. So just create the workspace here. Remaining. Yeah, it will take little time, not that much time, but yeah. Reflecting. Let me open. Let me start from here. In progress. So you see here, like this is Machine Learning Studio, wherein we have uh, different like categories like author, assets, manage. So under author, we have like notebooks, automated ML, and designer. Okay. So automated ML, what we are discussing now, we are going to see how it can be used. And then designer, without writing single code, just by dragging and dropping the components, we could able to like build the workflow, and we could able to build the model by using this designer. And of course, if you are a developer and if you want to really use the notebooks, and you have that option for like to create the notebooks and to write the code and develop the modules. Okay. So apart from that, we have like different assets like data sets, what kind of data sets we are using, and those all we could able to store, and what experiments we have done, that list we could able to get it from the experiments here, and the pipelines which we built, like in the designing what pipelines we have built. So those things we could able to see under these pipelines. And of course models, uh, whatever models we built on in this environment, those things, if it is registered model, then we could able to see those models here. And this is the endpoints which I like talked about right now. So wherein the deployed the registered model, and which is ready for the deployment, that can be stored at these endpoints. If you could see the list of those models, built-in models, as deployed version, in the form of deployed version, we could see here in endpoints. And of course, as I told you, like computing and data stores, remaining things will be there under this manage category. Okay. So I'm not going to discuss whole thing, but I'm just giving the overview of how automated ML can be used to build the model without like without writing any single code, just to configure the parameters, we could able to build the models. And of course, not only one model, we could able to like devise multiple models, and we could make use of those models. Okay. So let me create a new experiment. So just by clicking on that, we could able to create that, and uh, try to get the data set either from like local files, or from the data store, or from web files or open data sets. Whichever you want, you could able to get the data set from the locations, mentioned locations. I'm trying to get data set from the local drive. So my data set. Okay, so data set type tabular. Currently it is supporting tabular. So it will be using like Azure Blob Storage. So that's how it is supporting like both the structured and unstructured both things, both kind of data. Okay, I think the data is not here. Just give me a moment so that I can get the data.
Sure, sir. No worries, sir.
Okay, so just I got the banking marketing file, which is CSV file, and I am trying to upload it. Okay, so yeah, these are like delimiter, what delimiter we want to use. So you could use that here. And of course, we are using like CSV, so that's why like by default, comma separated and those all things are there. You could see here the different columns. And if you want to have the headers, then you choose this all files have the same header option, so that you could see the title of the column. Okay, header of the column. ID, age, job, marital status, education, default housing, and so on. Like lot many are there. And if you see the last column, which is Y, which is like target column, it will say that whether that customer is willing to take the fixed deposit or not. Yes or no will indicate that. Based on these parameters, we are going to train the model, and we will try to predict that results. Okay, and there is an option like if you don't want some fields within these list of columns, then you could able to like remove that by just clicking on this, whether to include or not. So that you could choose by tabbing this checkbox. Okay, so if this is not including in our like modeling. Okay, so these are like the settings what we have uh, configured for this, for creating the model. Okay, so now we have data set ready for our like modeling. So let us go to the next step for configuring the run. That means for setting up the modeling criteria. Okay, so let us give some name. My plus. This I'm giving some name, random name. It should be a unique name. So sometimes you may not get. And you could choose the target column, which is Y in our case. And yeah, if you have like already created compute resource is there, then you could use that. Otherwise, we could create the compute resource by clicking on the uh, create machine. Okay, just I'm giving like the bare normal. With some nodes I'm taking. Something I'm creating, configuring. And it will create virtual machine with these capabilities. So we are using that virtual machine to create the to run our experiment. So for that purpose, we are creating the virtual machine now. As I told you, like if you already have compute resource readily available, then you could make use of that directly. Otherwise, we could create it like so. Yeah. So now the compute resource is also ready for us, and configuration is also ready. And here I told you like you could able to create classification or regression or time series forecasting uh, machine learning things here. And as I told you, classification we are gonna do. So just I'm choosing classification here. And if you need really want to add deep learning also, you could add it here. And of course, any additional configuration which you need to add here, you could do it here. As I told you, we will be looking at AUC weighted metric, so that I am using. Okay. And exit criteria, just 1 hour I'm giving, so that within that 1 hour, what whichever model is performing better, that will be choosing, and that is the exit criteria. Okay, so these are all the settings what we could able to do it, and featureization also we could able to see like any features, any columns which you want to modify, you could do that here. Okay, so this is how we could able to create the experiment. Now if you see the status of this run or this experiment, it is not yet started, it is still under process. So once it gets started, then you could see the running status is running. Okay, what does it mean? The meaning of that is like internally what it is doing is it is see here the status is now running. So now during this process, what it will do is it will take one algorithm and it will build the model for that algorithm, and then it will try to evaluate that algorithm, and it will see what is the metric value for that algorithm. Okay, so during that process, it will be like taking multiple what do you say, like multiple algorithms and corresponding metric value for that algorithm. It will be calculating and it will be showing uh, as per like priority order, like descending order. Okay, so probably if I could show you one, let us wait for few more minutes to like at least build 1 or 2 models so that I can show you what in the background how it is going to uh, work, and what it is going to what kind of information it is going to show us, that I am going to show you. It will take bit more time, like maybe 1 or 2 minutes, so that yeah, these are like different options to see what how many child runs it is like generating under this particular run. And then if you want to see the logs for this experiment, then you could see the logs. And here you could see the models, which I already told you, algorithm name and what is the metric value, right? And what is the run of that, and then at what time it got created, and duration, status, those all things we could able to see. Just I'm curious to show you only at least one experiment, one algorithm, sorry. so that you could understand what is going on in the background. Just to give me 1 or 2 minutes. Dr. Aranji, almost I am going to close within like
It's okay, sir. No
four,
worries.
five
Take your
minutes.
time. Yeah, take your time,
Yeah,
sir. No
three,
worries.
to, 3 to 4 minutes I am going to complete. So
Yeah.
forgive me if I am taking more
No,
time.
no, no, sir. Talk is going on very good speed, and you can say people are very much keen to listen to you.
Thank you. And about this option, if you have any trouble in during the process, if you find any trouble in featureization or during the process any issues happen, then we could see under this tab we could see the problems and the corresponding issues happened during the process. Yeah, for initial process it will take few. Yeah, once at least one model if it could create, then I want to show that, and with that I will conclude.
Sir, you can see the chat window. There are so many appreciation messages, and people are also interested in getting the video. So those who are interested in getting the video of this talk, let me tell you that we were live on YouTube. So you can have the YouTube link. Dr. Vishal will share with you the YouTube link.
Okay, so Mr. Mandeep, I am not sure what is this automated hydroponics form, but I would say, I mean, for any application, after you get the data, then this is how we will be processing. Just we need to uh, build a model. By using that model, we will try to like uh, identify certain anomalies, you could say, and with that, we will try to address the problems which are arising in that application. Okay, so got like certain information like you could see here, data guardrails. So validation split handle like this, you could see here like class balancing detection, which is imbalance. Imbalance classes were detected in your inputs. So kind of messages you could see, and with that you could understand what kind of data we had. we could also see like logs here. Okay. Meanwhile, I will like it is taking time. Okay. Anyhow, I will show you after my concluding remarks. Okay. So yeah. So yeah, let me conclude this by summarizing what we discussed. So initially we start with the basics of IoT, and then we entered into what is the need of IoT edge, and then we saw one demo on uh, IoT, basically IoT application, wherein the device is sending data with lag of storing the data and generating data. So that can be um, achieved, that can be removed with the help of edge implementation. So that is where edge computing era has come up, and then then we could able to like address the delays which are happening with IoT technology with the help of deploying and preparing the solutions uh, by deploying the models which are created at the on premises as well as in the cloud. Okay, and the deployed models can be on the device on even at the device level also you could able to deploy those models, and you could analyze the data which are streaming data, you could say, or real-time data, and you could monitor what that data contains, whether the genuine data is coming or any anomalous data is coming based on the model uh, model built, and based on the model predictions you could understand uh, the insights of the data, from where you could see you could give the what do you say? You could give the insights, actions uh, to the end user who are like a part of this system. So this is how like we are working currently. We are working on this project, NSF project. Apart from what we are doing, like cyber forensics, for like cyber physical systems over here. Apart from that project, I am also as part of this NSF project, where wearable technologies we are applying, and mostly healthcare related work we are doing. This is general architecture I am giving you as a framework for you to work. And basically we are working on like health related um, issues and problems we are achieving with this architecture. Okay, so yeah, so by said that, let me see if I could able to get any models. Okay, I'm not able to still it is not showing up the models. So still it is
It
not showing
usually
up the
takes
models.
time, sir. Actually, it usually takes time because the data set was also large.
Yeah, so at least we got something which is not appropriate, but at least we got something. So uh, so see here, like we have like different algorithms which are not appropriate. I already told you, like, which is still in the progress, but yeah, at least I could show you this. It's not completed. Okay, anyhow, so this is how we could able to get the algorithms, like different multiple algorithms. Uh, they will like they have list of algorithms which will be uh, generating models for this algorithm, and it will try to give the metric value like this, and which will be descending order. This algorithm is giving 0.94 accuracy, AUC weightage, and if you see the X booster classifier, which is giving 0.93. So like that, you will be getting like lot number of algorithms with the metric value. So based on that, the topmost algorithm will be the best performing algorithm, the best model algorithm. So you could try to use that algorithm for like deployment and all. So deployment can be done like this. You just click on this algorithm and you have deploy option here. So if you click on this deploy option, then it will be asking you the details and which kind of compute resource you want to use uh, it for deployment, either Kubernetes or container instances. So that you could able to choose and you could able to use that. And by that way, once the model is deployed, and then it could appear here in endpoints. Okay, so yeah, so this is how we could able to uh, do the IoT analytics. Even real-time data also we could able to analyze, and we could able to get the insights out of that. So yeah, by said that, uh, that is
Thank,
my I am concluding my session with that. So if you have any questions or concerns, let me know. Thank you very much for like providing this opportunity, and I am very happy to collaborate with you in future.
thank, thank you, Sureshji. Thank you so much for such a nice and informative session. As you can also see from the chat box, there are so many appreciation messages. Very informative, really awesome session. Informative, nice. People are saying thanks to you. And I
Thank
can
you very
also
much.
see that how nicely you demonstrated IoT Hub and Auto ML with Microsoft Azure platform. People could have understood that how they can utilize it for their research work also. And we would also like to collaborate with you in near future with some projects that do in healthcare, sir.
Sure, certainly.
So I have noted down your email ID. We will try to catch you through your email, and later on we can have some more discussions. And if you could spare some more time, then we would also like to arrange a session of yours for only for students that are
Okay,
enrolled in IoT only.
definitely, no problem.
That will be a specific session for IoT students only, and there will be only 50 to 60 students, if you permit us, sir.
No problem.
I'm seeking for
I'm
your
happy.
consent in the on this open platform. So if you permit, then we will arrange a session specifically of yours only for IoT students.
Sure, definitely.
Thank you so much,
I'm
sir.
happy to
Thank you.
collaborate with you.
Yeah, thank you. So nice of you, sir. And thank you all the participants for listening so patiently. And I hope that all the questions were answered in between the session by Suresh ji. So with this, we would like to conclude this session of this FDP. And there is one more information that tomorrow we are having two sessions. One is at 11 to 1 p.m. and another is at 3 to 4:30 p.m. So hope you are aware of that. Thank you, everyone. Thank you, Suresh ji. Thank you so much.
Thank you, Arunji. Thank you very much, everyone, for patiently listening to my lesson. Thank you.
Thank
Bye,
you so
everyone.
much. Bye bye. Everyone, bye bye.